So hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode daily problem of the day, and the problem is longest strictly increasing or strictly decreasing subarray, and we have to given a array of integer nums and written the length of the longest subarray of nums, which is either strictly increasing or strictly decreasing. And then also now look at their problem statement, and then we have to look their example test cases, then their implementation part. So here, so first we have to given a array of nums, and this array of nums, this is an integer, and our task is to find the length of the longest contiguous subarray, like longest contiguous subarray, like we have to calculate LCS. Okay, and this and also we have given first strictly increasing. Okay, this strictly increasing means each element is greater than the previous one. Each element is greater than previous, and the same thing for this one. Strictly decreasing means each element is smaller than the previous one, and the same thing. And the for example, strictly increasing means if we have to given 1 2 3, and this 1 2 3, the strictly increasing, this is strictly increasing because of 1 less than 2, and you can say 2 less than 3, and this is the strictly increasing. And now one thing is 2 3 4, and this 2 3 4, sorry, this 3 3 4, and this 3 3 4 is not strictly increasing because of here 3 is equal to 3, and this is not strictly increasing, and you have to take care of both the parts. Like here we have to discuss strictly increasing, and here we have to also discuss if the same value are present, then there is no strictly increasing elements. And now strictly decreasing means here 5 4 3, and this 5 4 3, we have 5 greater than 4. Okay, and you can say 4 less than 5. Okay, and also we have the value of, and then you can say this one. Okay, and also the value is this one, and so this is strictly decreasing value. And the same thing if we have take 3 2 and 2. Okay, and this 3 is also be our strictly decreasing part, but here 2 is equal to 2, this is not strictly decreasing because of all two values is same. And I hope you understand the difference between strictly increasing and strictly decreasing. And our constraint we have to given here, the constraint are 1 less than is equal to nums dot length, and less than is equal to 50, and it means 1 less is equal to nums is equal to 50, and this means the array size is small, so that O of an approach we have to follow for optimal solution. And the same thing for 1 less than is equal to, and nums dot length less than is equal to 50, and this means we have all the numbers are small positive integer. Okay, and so now let's look at their example test cases so that you can understand how actually this work. And here 1 4 3 2 3 3 2, 1 4 3 3 2, and here we have to find strictly increasing and decreasing, and the strictly increasing order is we have 1 2 3 3 and 1 comma this one 1 comma 4, or and then strictly decreasing means 1 1 2 3, like this one, like 1 2 3 3 and 4. Okay, this 4, and then you can say 3 2 and 4 3. Okay, this 4 and 3. So how many subarrays we have to identify? We have to identify two subarrays, then we have to return 2. And the same thing for this one, this 3 3 3 and 3. Okay, and this 3 3 3 3 means we have to find the strictly increasing and decreasing order, and the strictly increasing order is 3 3 3 and 3, and same for decreasing. So that's why all strictly increasing and decreasing is same, so then we have to return 1. And then this one is, this example is 3 to 1, and this 3 to 1 we have to calculate the strictly increasing order, and the strictly increasing order is 3 2 and 1, and here we have 3 2 1, and this one 3 2, and you can say 2 1, and this 3 2 1. And which is the maximum of all these subarrays? This is the maximum. We have to find the maximum subarray. Okay, and here the maximum is what we have to get. The maximum is these two, so that's why we have to return one value. So one maximum. So how many maximum element are present? Two values. And here same thing for here, 3 2 1, 3 2 1, and so maximum is 3. Okay, and also now look at their coding implementation part, so that you can understand how you actually find the uh, increasing and decreasing and then maximum value. Okay, and so this is our simple code, and this code, first we have their increasing, decreasing and result value, and all I have initializing with 1, and then we have to check with all the values. And now we have their iterate with their loop for index 1 comma n minus 1, and this if condition we have to check with if nums of I greater than is equal to greater than nums of I plus I minus 1, and then we have to increase plus plus, and then decrease is equal to 1. Means if the count number is greater than the previous count, here if the previous count, and then we have to increase the sequence. Here we have to increase the counter, then we have to reset their decrement value. And the same thing for here, we have to if the number is smaller than the previous one, then we have to decrement, and then increment counter is 1. And else we have there if number are equal, then we have to reset both the values. Like if the nums of I is equal to nums of I minus 1, and this value is same, and then we have to reset their values. And then here we have to find their maximum is like maximum of update result with maximum length, and then we have to return their value. And now look at their time and space complexity. So the time complexity of this code is we have to iterate a loop for one loop, so that's why O of n time this is work. And the space complexity of this code is we have to declare increase, decrease and result, and the space complexity is O of 1. So I hope you understand how actually we have to work with their values, and how we have to find their maximum here. And also we have discussed here like what is in strictly increasing and decreasing, and if we have their equal to, then we have not strictly increasing and decreasing. That's why here we have this one. Uh, like we have to reset our values, increase 1 and decrease 1. So thank you everyone, thank you so much.